All right, so now we're going to talk about what happens after the egg and sperm um, combine to create that zygote. The zygote begins to divide as it travels down the fallopian tube. So remember that fertilization typically handles in the fallopian tube. So at first it divides, but it doesn't increase in size. So we end up with smaller cells with each division. Within about 3 days, there's a 16 cell morula. It's like a solid ball of cells. Think of like what a raspberry or blackberry looks like with all the little cells. Okay. The morula enters the uterus and it floats around freely. At this time, the cells are beginning to be divided by fluid into two tissues. The trophoblast becomes the placenta and the embryoblast becomes the embryo. So that solid ball of cells begins to develop a space in the middle that's filled with some fluid. That space consolidates into a blastocyst cavity. So we have the fluid forming in between those cells, and eventually when that fluid becomes kind of like a cyst in between, then we have a blastocyst. So the morula is a solid ball, and then when we start to get some fluid that separates that into two kind of bunches of cells, then we have a blastocyst. The zona pellucida starts to disintegrate. Remember, the zona pellucida was protective. It prevented other sperm from getting in after the first one. Now it starts to disintegrate, and the blastocyst will land on the side of the uterus somewhere, and it will start to embed in the endometrium. That happens about 6 to 10 days after conception. So about 6 to 10 days after fertilization of that ovum, now we're implanting. Chorionic villi start to extend from the trophoblast. So remember, we've got the blastocyst. It lands on the wall of the uterus. The zona pellucida disintegrates, and the trophoblast cells start to displace some of the endometrium, and then the trophoblast starts to extend little finger-like projections down into the endometrium. Okay, and that's the beginnings of where the placenta is going to be. We've got little finger-like projections going into the endometrium. So the maternal blood flow goes around those little villi, and that's where oxygen and carbon dioxide exchange and nutrients and waste exchange occurs. Okay. Those vascular complexes eventually will become the placenta. So 3 weeks after conception, we have an embryo with 3 basic layers. The ectoderm is going to become one set of organs and tissues. The mesoderm is going to become another set, and the endoderm is going to become another set. Okay, so we've got 3 layers. By about 8 weeks, all of the critical structures have started to form. But when we talk about the cardiovascular system, we've got a very, very rudimentary heart. When we talk about the gastrointestinal system, it's basically just a tube. The neurologic system is a tube. So in that first 8 weeks, all of those structures start to form, but they really don't look like their final forms. At implantation, we also start to form some membranes. The trophoblast develops chorion, which is going to be the placenta side of the membranes, and chorionic villi. So that's going to be the fetal side. The amnion is, that's the placenta side. The amnion is the fetal side, and those membranes, there's 2 layers to that membrane that's eventually going to form the bag of waters. So those 2 layers are adhered together, but one layer is from the fetal side and one layer is from the placental side. That cavity, remember we talked about that cystic cavity where the fluid was, that becomes the amniotic space. Okay. Now the amnion, the fetal side, we have the membrane, and then we also have the umbilical cord that takes blood vessels into or out of between the fetus and the placenta. Okay. So we start with the chorion, that's part of the placental side, the amnion, that's part of the fetal side, and eventually as they grow, they become a two-layered single membrane. Amniotic fluid, which is what's in that cavity around first the embryo and eventually the fetus, initially is fluid that's come from the maternal blood. Eventually, as the embryo becomes a fetus and their body systems start working, it can be respiratory and gastrointestinal fluid, and then eventually it's primarily made of urine. So after about 11 weeks, the fetus is making urine, and urine begins to be more and more of that amniotic fluid. So by delivery, fetal urine is the major component of amniotic fluid. That's really important to know, because remember, one way we can tell about perfusion is urine production. If the kidneys are being perfused, they're going to make urine. So if we have low amniotic fluid, we may have a fetus that's not getting good perfusion to their kidneys. So amniotic fluid functions as an oral fluid. So the fetus drinks the amniotic fluid because it helps the development or practice using the GI tract. The fetus also urinates into that fluid, so it contains waste. Remember that there's no the GI tract is not colonized yet, and the urinary tract there's very low bacterial levels within this. So we're not looking at infection risk with drinking and voiding into the same fluid. It helps maintain fluid electrolyte balance. It acts as a cushion. So the fetus eventually can move around in that fluid. That allows for movement and musculoskeletal development. If we restrict movement on the fetus, then that can impact their musculoskeletal development. It's a barrier to infection. It helps with fetal lung development because the amniotic fluid itself is not going in and out of lungs. There's a specific fluid already there, but the osmotic pressure of the amniotic fluid causes that lung fluid to be pushed further and further. The fetus starts to practice respiratory movements, and moving that lung fluid in and out further develops the lungs. So we have to have amniotic fluid there, even though it's not amniotic fluid that's going into the lungs. And that fluid helps prevent the fetus from getting tangled in the membranes. The yolk sac forms on the opposite side of the embryonic disc from the amniotic cavity, and it actually is a temporary source of maternal nutrients and oxygen for the embryo while the placenta is forming. So the placenta, remember the placental side of that blastocyst starts to put finger-like little projections, villi, down into the endometrium. That begins to form a placenta, but during the process of that, the yolk sac helps to transfer oxygen and nutrients. After about 3 weeks, a primitive heart begins to beat. Now that heart is very primitive. It's like basically 2 tubes. Okay, so we do have, where were we at? By about 3 weeks, we have a primitive heartbeat, but that is a very, the heart is like basically 2 tubes, and we start to have a primitive heartbeat. In the 4th week, the embryo folds in. Part of the yolk sac becomes part of the digestive system, and the rest of it degenerates and separates by about the 5th or 6th week. Okay, now the umbilical cord. How is that umbilical cord formed? Because we talked about it, but we didn't really talk about where it comes from. By day 14, the embryonic disc, the amniotic sac, and the yolk sac are attached to those chorionic villi by a stalk. So remember, the chorionic villi are when the placenta side, or what's going to be the placenta side of that blastocyst, start to make their little finger-like projections down into the endometrium. And then on the other side of this little collection of fluid, we have the embryo. Well, there's a stalk that connects the chorionic villi with the embryo. Okay. In about the 3rd week, we start to develop some blood vessels in that stalk. After the embryo folds in the 4th week, that stalk becomes an umbilical cord. And 2 arteries carry blood from the embryo to the chorionic villi, and 1 vein returns blood to the embryo. Okay, so arteries go away from the fetus because it's the fetal heart that's pumping that blood to the chorionic villi that will become the placenta. Gas exchange, nutrient waste exchange occurs there. Vein comes back from the placenta to the fetus. Okay, in the next section, we're going to talk about the placenta more in depth.